सो हेलो नमस्कार टू द ऑल केमिस्ट्री लवर्स, डॉक्टर्स एंड इंजीनियर्स ऑफ द नियर फ्यूचर। मैं विजय कुमार सोनी आपका हार्दिक स्वागत करता हूं इन केमिस्ट्री वाला चैनल रिगार्डिंग टू एज पर लॉज एंड ऑर्डर एंड द वीडियोस रिगार्डिंग टू केमिस्ट्री। केमिस्ट्री के रिगार्डिंग क्लास 11 से बहुत से डिजायर आई साहब कब से आपने सिलेबस तो अपडेट कर दिया, बट वीडियोस आप कब से अपडेट करेंगे। सो फ्रॉम टुडे ऑनवर्ड्स वी आर गोइंग टू स्टार्ट द जस्ट वीडियोस अपलोडिंग इन द सीरीज। इसी सीरीज में सबसे पहले मैं बात करना चाहूंगा इंपॉर्टेंट टॉपिक दैट इज द ऑर्गेनिक केमिस्ट्री। और ऑर्गेनिक केमिस्ट्री के लिए मैंने आपको बताया था देयर आर टू इंपॉर्टेंट चैप्टर राइट नाउ इन क्लास 11th। one of the is your GOC, general organic chemistry, and another is your hydrocarbon. So first of all we'll go with the just chapter number 12 according to old syllabus but according to modern syllabus. So we'll not take the numbering of the chapter, we'll call it GOC. So this is the GOC. GOC. The meaning of GOC is your general organic chemistry. General organic chemistry. The full form. It's a very important chapter beta because it takes a lot of time to complete the each and every topic. So we'll go with the just small videos, and you have to just write the matter in your notebook because it's too important. First of all, before starting the GOC, I would like to go with the just carbon. There are 118 elements. Total number of elements are 118. Total elements. According to modern periodic table, MPT means modern periodic table, which was proposed by who? Bohr. So according to modern periodic table, there are 118 elements, and out of them one of the element, that is the just element, is your carbon. This is the carbon. If you will go with the carbon, then its symbol is your, this is the symbol is your C. Atomic number, Z means atomic number, it will be your 6. A means atomic mass, that will also 12. If you will go with the just number of protons, then protons will be as a positively charged particle, they will as a 6, and electrons as a negatively charged particle, they will also 6. And the filling of electron according to the 10th standard electronic configuration should be 2 and 4. After then, I would like to go with the number of neutrons. Neutrons can be calculated by the A minus Z, where A is the atomic mass, that is the 12, and Z is your atomic number, that is your 6. So it will be 6 neutrons. 6 neutrons. We can call them 6 also because we have mentioned here. If we'll go with the just further structure of the carbon atom, then you can take, this is the structure of carbon atom. Then according to 9th standard, this is the nucleus. It exists two particles, one of the proton, another neutron. So here will be 6 proton, 6 neutron, and surrounding to it, first of all, it will be filling of 2 electron because of it follows the stable configuration as a 2, 8, 8, 18 and 32. So first of all, it will be filling of 2 electron. After then, it will be 8 electron. So here should be 8 electron, but here is only 4 electron. So 1, 2, 3 and 4. So this was about the structure of the carbon atom. Now I would like to go with the further regarding to carbon. We will take a lot of matter. According to just chemistry of 11th, electronic configuration will be 1s2, 2s2, 2p2. How it is possible, we'll discuss in the further videos. No doubt I'll help you regarding to each and every matter. Electronic configuration is your 1s2, 2s2, 2p2. This is the carbon regarding to. If we'll go with the just valency, this is the valency. As we know that here are just 4 electrons, and according to stable configuration here should be 8 electrons, but here is 4 electrons. So regarding to 4 electron, what it can be? Carbon क्या करेगा? No doubt 4 electron की requirement है. That's why its valency will be 4, not plus, not minus. That is called as oxidation number. So valency will be 4. That's why it is called as tetravalent element. Tetravalent element. If the valence is 1, then monovalent, for 2 bivalent, for 3 trivalent, for 4 tetravalent. So carbon is a tetravalent element, means it exists 4 valency, and these 4 valency may satisfied by either 4 single bond, may satisfied by either 2 single and 1 double bond, may satisfied by 1 single and 1 triple bond, and may satisfied by just 2 double bond, like this. Now the time to discuss how it can complete the 4 valency. So if we'll go with the just valency, then carbon doesn't exist as +4 and -4, means ये पर्टिकुलर ना तो 4 इलेक्ट्रॉन लूज करता है, ना ही 4 इलेक्ट्रॉन शेयर करता है. ऐसा क्यों? मीन्स इट डजंट फॉर्म एनी काइंड ऑफ दी आयंस का फॉर्मेशन नहीं करेगा, तो पर्टिकुलर इट डजंट फॉर्म आयनिक कंपाउंड, मीन्स आयनिक कंपाउंड का फॉर्मेशन नहीं करता है. व्हाई? If we'll go with the +4, C+4, then it should be required to remove 4 electrons from the outermost shell, and it will require a large amount of energy to remove the 4 electron, and it is not possible to give the amount of energy. That's why it doesn't exist in the C+4. So you will say large amount of energy will require, which is not possible to provide, which is not possible to provide. We don't have proper source provide. Second is your C-4. For the -4, there should be gain of 4 electron. So now here will just 2 and 8 electron. Total will be 10 electron. But protons are still 6. These 6 proton cannot hold to the 10 electron. That's why it doesn't exist in -4 form also. So you can say over here just 6 proton cannot hold 10 electrons. So it also doesn't exist as a C-4. So what it may exist, and it exists basically property of covalency. Covalency means it exists sharing of electrons, and due to having the tendency of covalency, means sharing of electron, it always forms covalent compound. This was regarding to just initial part as an important part. Now the time to discuss about the further regarding to GOC, and now we have started, so we'll not stop till then completion of your syllabus. So stay with me, like the video, share the videos, subscribe the video channel, and it also, you should also share with the other person who want to do something in their life. So now the time to discuss about the further property. If we'll go with the further, then carbon exists covalency. Yeah, you can say this forms covalent compounds. That's why we can say that due to property of covalency, it exists 50,000 compounds as a non-compounds. It's a just wow, we can say. So if we'll go with the further, after the covalent compound, it exists the property of catenation. Property of catenation. Catenation means formation of tendency to form, you can say, tendency to form long open and closed chain मीन्स पर्टिकुलर ये इलेक्ट्रॉन के शेयरिंग के थ्रू कैटेनेशन की प्रॉपर्टी के कारण से लॉन्ग ओपन और क्लोज चेन का फॉर्मेशन करता है. Now I would like to go with the that is the isotopes. If you will go with the isotopes of the carbon, then there are three isotopes of the carbon. Three isotopes. What is the meaning of isotopes? What is the meaning of isotopes? You can say having same atomic number, means Z atomic number with different atomic mass. Different atomic mass means A. Those are known as just isotopes. What are the isotopes of the carbon? These are very important. We can take just C6 to 12, C6 to 13, C6 to 14. These are the three isotopes of the just carbon. Carbon 6 to 12, carbon 6 to 13, carbon 6 to 14. If we'll go with the just atomic number, then Z should be same. That is the 6 and 6. Here is the A. This is your 12, 13 and 14. If you are confused about the just A and Z, then you can see over here. Any element can represent as follows. This is the X is the element. At the base it will be Z, it will be in the power, it will be A. So Z is your, you can say, atomic number. This is the atomic number, and A is your atomic mass or mass number. Atomic mass or mass number. So now it's convenient for you. This is the atomic number, that is same, and atomic number, atomic mass is different, 12, 13, 14. If you will go with the C14, then this is the most important radioisotope. It's a radioisotope. What is the meaning of radioisotope? Means it eliminates some invisible particles like alpha, beta and gamma. That's why its half-life period is denoted by T half, will be 5770 years. It means इसका 1 ग्राम 0.5 ग्राम में इतने टाइम में रह जाएगा. मीन्स इसका इतने टाइम में अमाउंट हाफ रह जाएगा जितना भी आपने क्वांटिटी ले रखी है इस टाइम में 5770 ईयर्स में. दैट्स व्हाई इट इज यूज इन कार्बन डेटिंग प्रोसेस. It is used in carbon dating process. Carbon dating process. What is that? The process through which we can define the age of fossils. Age of fossils regarding to different animals, living beings. This was about the isotopes. Now I would like to go with the just further. Then that is also important. What is that? This is the, you can say, allotropes. If you will go with the allotropes, then what is the meaning of allotrope? First of all, we have to know. So allotropes are just, you can say, having same physical properties with different chemical properties. Those are known as allotropes. And if we'll go with the just this phenomenon, then this phenomenon is called as allotropy. entropy. This is the very important. Because of 1 to 20, many of the elements exist in different state, having the just same chemical composition but different physical properties. They all are known as allotropes. So this is the time to discuss about the carbon. If we'll go with the allotropes of the carbon, then carbon exists in two allotropic forms. One of the is your crystalline. This is the crystalline allotrope, and another is your amorphous. If you will go, what is the difference between crystalline and amorphous? Then crystalline form acts as the regular arrangement of the particle. You can see, you can learn about the just crystalline and amorphous like this. We can take over here. This is the plus. These are the arrangement of the particles. Plus, minus, plus, minus, plus, minus, plus, and minus. But if, then this is called as crystalline form or crystalline allotrope, regular arrangement of the particle. And further, if you want to take this amorphous, then it can be understood by following diagram. This is the plus, minus, minus, plus. This is the minus, plus, plus, and minus. Here is the irregular arrangement. So this is called as amorphous form. Amorphous. Many of the students are confused how much allotropes of the carbon are possible. They told me just three: diamond, graphite, and fluorine. These are the example of crystalline allotrope, not to be allotropes. So there are two allotropes of the carbon, crystalline and amorphous. If we'll go with the examples of the crystalline, then we can take first example is your diamond, second example is your graphite, third example is your fluorine. Fluorine is the best example. If you will go with the amorphous, then you can take a lot of example. Charcoal, you can take coke, ya coal, etc. The important allotropes are diamond, graphite, and fluorine. We will discuss further. Read the properly the matter and what is the basic thing. So now we'll go with the further. What is that? After sharing the allotropes, we'll go with the diamond, graphite, and fluorine. Diamond, graphite, and fluorine. That is too important. If we'll go with the diamond, this is the diamond. Then in diamond, each and every carbon will surrounded by 4 carbon atoms. Means valency will be satisfied like this: C, and C. Further, each and every carbon will be surrounded by this 4 carbon atom. So here will formation of a compact structure, compact 3-dimensional structure. This is the structure of the diamond. So you can say, due to formation of 3-dimensional compact structure, it is hard in nature. That's why it is used as a glass cutter also. Now the time to discuss about the conductance. If you go with this carbon, then each and every carbon is surrounded by 4 carbon atoms, so none of electron is free. So due to absence of free electron, diamond is Diamond is insulator of current, means it doesn't exist flow of current. Further, if you go with the just uses, then you can say first as a glass cutter. Glass cutter means glass को काटने काम में आता है. Second is your in the formation of ornaments. Ornaments बनाने में भी काम में आता है. So these are the two important use of the diamond. Now the time to discuss about the next is your graphite. This is the graphite as a allotrope. Graphite is a Latin word. It is developed by grapho, and grapho means just used to write something. Used to write something means लिखने के जो काम में आता है, that is called as just graphite or grapho. Lead pencils में graphite होगा, that is also called as graphite, but we call them lead pencils because of it exhibits a luster similar to lead. That's why that is called as lead pencils. If you go with the graphite, then in graphite, one thing is also for the alarm class. Here, carbon will be in sp3 hybridization state. What is the meaning of hybridization state? We'll discuss in this chapter. Hybridization state for the carbon is your sp3. फिलहाल इतना सा जाने कि whenever कार्बन की 4 valencies present हो, just single bonded हो, then it will be sp3 hybridization. Now the time to discuss about the graphite. In graphite, each and every carbon will surrounded by 3 carbon atom and forms hexagonal. This is the most important word. Hexagonal layered structure. Hexagonal layered structure का formation करता है साहब. This is very important. Hexagonal layered structure. What is the meaning of hexagonal layered structure? We'll discuss over here. This is the graphite. If we'll go with the structure of graphite, then you can take as follows. Each and every carbon will be surrounded by 3 carbon atom and forms a hexagonal layered structure. This is the hexagonal layered structure. This is the another hexagon. You can say this is the hexagon. You can see each and every carbon is surrounded by 3 carbon atom as follows. Here will also carbon. Here and here. ये इसके साथ में partial overlapping. ये वाला कार्बन इसके साथ में upper carbon for this with the just you can say with this will be with this and this will be with this. कुछ इस टाइप से hexagonal layer structure layer के रूप में बनेगा. And due to formation of hexagonal layer structure, these layer can slip over one another. एक दूसरे पर slip कर सकती है. That's why it exists of nature. So it is soft in nature. One thing. If you go with the just hybridization state over here, then you can say the carbon will be in sp2 hybridization state. sp2 hybridization state. What is the meaning of hybridization state? We'll discuss in the further videos in this chapter also. So hybridization state is sp2 means each and every carbon is surrounded by 3 carbons, so it will be one of the free electron. because of there are 4 electrons in the outermost shell of the carbon. So due to having free electron, as you can say 1 electron, it acts as good conductor of electricity. Now the time to discuss about the uses. This is the minus for the electron. Uses के regarding बात करें, then it is soft in nature, that's why it is used in as a lubricant in just aircraft. And second is your as pencils or lead pencils. And third is your used to form different electrodes as a cathode and anode. So this was about the allotropes of the carbon as a diamond and graphite. We will see with the fluorine also. See the matter properly. Now the time to discuss about the fluorine. It's a very important, and remember one thing, diamond is one of the allotrope जिसका कोई दूसरा सब्सटेंस के थ्रू फॉर्मेशन नहीं कर सकते. दैट्स वाई जब भी आप डायमंड खरीदने जाते हैं तो एक स्टेटमेंट आपके पास में होगा, बिकॉज ऑफ थर्मोडायनेमिकली और केमिकल काइनेटिकली डायमंड इज स्टेबल. सो विल से डायमंड फॉर एवर, हीरा सदा के लिए वर्ड यूज करते हैं. सो नाउ द टाइम टू डिस्कस अबाउट द fullerene. This is the fullerene, another third allotrope. If we go with the fullerene, then many of the students still are confused. Who discovered? Discovery by Kroto, Kern and Smalley. Kroto, Kern and Smalley. इन्होंने तो तीनों ने जो स्ट्रक्चर प्रपोज किया, इट वॉज द सिमिलर विद द जस्ट आर्किटेक्चर. बकमिंस्टर fullerene. दिस इज द बकमिंस्टर fullerene. ये एक आर्किटेक्चर था. fullerene उसके सिमिलर स्ट्रक्चर था. सो दे डेडिकेट द नेम टू दिस पर्सन. That's why it is called as fullerene, also called as buckyball, also called as shocker ball also. If we'll go with the just hybridization, then again carbon will be in sp2 hybridization, and it exists. There are a lot of species of the fullerene. C60, C70, C80, C90. Here C60, 70, 80, 90 is the number of carbon atom. So if we'll go with the stable type of the fullerene, that is the C60, which exists 32 phases in the structure. It exists 32 phases where it will be just 20 as a hexagonal, HP you can say hexagonal, and 12 will be as a pentagonal as a faces. 20 hexagonal and 12 pentagonal. If you go with the use, then it used as superconductor. And what will be the structure? You can draw it as follows. This is the structure of fluorine. 1, 2, these are the number of electrons. You can show them in a sphere like this by joining the bond like this, like this, like this, and so on. We have to show this pentagon and hexagon ring. So you can show as follows: 1, 2, 3, 4, 5, 6, and 7, and 8. You can take. If you want to show the pentagon ring, then it can be denoted by as follows. By erasing it, this is the pentagon ring. This is the pentagon face. If you want to show the hexagon also, then you can show this is the hexagon, and rest it will be as follows. You can make them as follows, as follows, and as follows. So this is the structure of fullerene. Structure of fullerene. So this was about the allotropes of the carbon. We'll take another video regarding to introduction of the carbon. Till then, शुक्रिया, धन्यवाद, इन्हें विश्वास जताते रहिए। एंड 11th क्लास वाले स्टूडेंट स्टडी स्टार्ट कर दें, नोट्स प्रिपेयर करना स्टार्ट कर दें, और जिस किसी को भी हेल्प करना चाहें उसके साथ शेयर कराएं, मैक्सिमम शेयर करें, लाइक करवाएं और सब्सक्राइब करें, ताकि हर एक मटेरियल टाइम टू टाइम आपको अपडेट हो सके। तब तक के लिए शुक्रिया, धन्यवाद।